Want we krijgen nu een heel bijzonder onderdeel. Because we have to switch to English now. There's a 9-hour time difference with California, but we do have a direct connection, I think, with Forrest Vleger. Let's see if he's already there. Forrest is Director Software and Design Automation at Katerra, and earlier this morning we're already mentioning Katerra a few times, because what makes Katerra special? Katerra, like car manufacturer Tesla, controls virtually the entire supply chain. And I think Katerra is an example for a lot of people watching this webinar, and they're very curious to know how they work, what their philosophy is. And I do see Forrest now. Hello.
Good afternoon.
Good afternoon, yeah. And in your case, I think it's around midnight, isn't it?
Yeah, I'm actually on the East Coast America time, so early morning.
Early morning, okay. Hopefully you're awake, because we're very curious about your presentation and looking forward what you're going to tell us about Katerra. And to be honest, hopefully we hope you can copy a little bit what you're doing over there.
Absolutely, happy to be here. Thanks for the opportunity to present. So I lead the technology team at Katerra. So we do have an in-house software team, and I'm going to speak specifically about how Katerra is addressing this vertical integration challenge and the challenge of localization from the perspective of technology. But before I do so, I'll explain a little bit about the company overall. As mentioned, Katerra is a kind of vertically integrated end-to-end service provider, providing architecture, design, offsite fabrication, assembly, and materials. Are you guys seeing the slides okay?
Yes, we do.
Okay, perfect. And the company itself has market experience in quite a variety of different building types. It's grown quite rapidly over since its founding in 2015. Some of that growth has been via acquisition. So we play the role of the general contractor for quite a variety of different building types, as you're seeing on the screen now. We also have a vertically integrated sort of design build, and that currently is limited to multifamily apartment buildings and commercial office. So we have a wood and light gauge steel multifamily office product, which is a 3-story building product, and then an office building that's made out of cross-laminated timber. And those are the two sort of vertically integrated design products that Katerra is offering today, with plans to expand into additional building types in the future. In terms of the industrialized construction component, we have 2 active factories today. We have a light gauge steel and stud panelized construction factory in Tracy, California. That is also doing cabinets and windows. That is the image that you're seeing on the bottom left. We also have a mass timber factory or CLT factory in Spokane, Washington, on the west coast of the U.S., making panelized CLT panels. And finally, we have a precast concrete facility in Bangalore, India, that serves the India and Saudi markets with volumetric precast construction. So in terms of the focus of the talk, I think I will highlight 3 areas where I think the industry is going and discuss briefly Katerra's approach. So the first being industrialized construction. The reason for that, I mean, I will go quickly through this, as the audience is probably familiar. I mean, this is the real price of housing in the U.S., normalized for the cost of land. And you see it's gone up more than 5 times in the past 50 years in terms of real costs. And the relative balance of labor and material has remained relatively static in that time, with the majority of the cost being labor by a small margin. This, of course, varies by the market. But if you compare that to sort of other manufactured building products, Katerra was founded by two executives from the electronics industry, who were building products such as the ones you're seeing on the screen, and noticing that the real cost in a shorter period of time has gone down through advanced manufacturing and material innovation. So the thesis, of course, is to apply that to industrialized construction. We're seeing in many of these products the labor component is less than 20% of the overall cost. Katerra is approaching this challenge, which is a little bit different than those other products, with the need for mass customization. And the reasoning for that is, I think, the unique environmental factors that impact buildings. I'll direct this to the United States, but it applies to many other geographies. For example, here we're looking at a seismic hazard map of the U.S., and using automated design, we actually estimated the cost of the structure in all of these different regions. And due to the different, seismic and lateral requirements for that 24-unit, 3-story multifamily housing product that I mentioned briefly earlier, the cost of the structure more than doubles depending on where it's located in the country, due to the different structural requirements. We see on the mechanical system side less capital cost variation across the climate zones in the U.S. But if you're looking to optimize for operational or life cycle performance, it's equally important to have, we have quite significant variations in terms of operational efficiency if we're not able to customize the systems to this locality. And finally, from a market perspective, these numbers are indicative and not accurate today, but the cost of labor in the United States for site construction is more than a 2x variance depending on where you're located in the country. I'm typically based in the Bay Area, which is one of the most expensive areas for on-site construction. And so when you're developing a industrialized solution, you want to vary the level of completion or the amount of work that you do in the factory by region. And so the solution has to be customized to allow you to do more or less work in the factory depending on the local labor economics. So Katerra is approaching that through an automated design approach, which I'll cover briefly. So, of course, like many other designers, this is the 24-unit apartment building that I mentioned. We have standardized units that can be combined in different ways. In this case, we have 12 different standard units that are combined into these 3 building blocks of the apartment building that we call chassis, the center core block and right and left ends. And with a relatively small standard number of units, we can achieve many thousands of different variations of the building types to meet different customer criteria using a relatively standard component. We also apply software design automation to reduce effort. So in many cases, fabricators have to remodel a building virtually from scratch to create the fabrication model that drives machines, produces shop drawings. We've developed technology that takes just the design drawings and is able to read metadata out of those drawings to produce a fabrication model as you're seeing. Due to time, I will just cover briefly that we've looked at plans like this that look at all of how much effort is spent in different aspects, in this case of creating a fabrication structural model, and which of those tasks can be automated. through software. And so to date, we've reduced the effort to about a third of what it was late in 2018 by developing software automation to support the business. That has created kind of some interesting changes in the skills and experience that we've required on the design side. Before applying the automation, we had a very small number of experts defined as more than 10 years in the industry. The ideal skill set after applying automation is that we need much more experienced designers as a relative percentage of the total, because most of the basic tasks have been automated, which has been, in terms of young designers entering the industry, we've been recruiting and having a lot of success finding young designers that have software or visual programming skills coming out of university, and so they're often contributing, being paired with experienced designers and contributing as the tool builder to help design some of these software tools. So not seeking to replace the designer, but just to enable the designer to focus on higher level, more challenging problems rather than the details of, say, for example, modeling details or designing pipe routing. So that's one approach, is applying some automation to the design to achieve that mass customized solution. What is, I think, most exciting is once we have sort of industrialized construction and a data-rich construction environment or production environment and automated design, we can get to interesting iteration here between the two. So I'll pick a very simple example, which is just a typical wood timber stud wall. Both of these types are roughly structurally equivalent, but given Katerra's factory capabilities, one is about 30% cheaper for Katerra to make. So how are designers aware of how to make these type of decisions to come up with the most economical designs? And so this is a trivial example. In some cases, it becomes more complex. The way we do that is we capture data. This is a layout of our factory and all of the different workstations. And we capture how long each panel spends at each workstation and what materials are applied. And that allows us, using techniques like machine learning, to build a predictive model that can predict the total manufactured cost of arbitrary assemblies that we haven't yet designed, which enables us to kind of change the role of the engineer. So instead of the engineer specifying a particular construction, the engineer in this case is specifying like a performance that they need. I apologize, it's a bit small, but structural performance in terms of bearing capacity and shear capacity, structural parameters of the wall, and they enter the range of options that they're willing to consider. And then the system, using real-time information, is suggesting to them the most economical, in this case, stud wall designs that are easiest for the factory to produce at that moment of time, because the factory is also, changing capabilities and layouts, at least in our case, on kind of like a quarterly basis. So that enables us overall, in terms of looking at the building cost in general, to look at millions of different design configurations of the building and to try to optimize for cost. So in this case, we're able to reduce the cost of walls by 10% by optimizing to our factory capabilities. So we're working in this area. This is one example. You could imagine other systems in the building, for example, the mechanical, electrical, and plumbing systems, which have similar challenges in terms of laying out a given system for performance. And just from a technology perspective, I'd like to highlight one other area that we've been active, which is helping to forecast material demands using virtual construction. So we've developed a process by which all of the active design models that we have. We're essentially creating bills of materials and forecasting material demands 12 months in advance. In some cases, we don't have complete design information. For example, the structural design of the building or the mechanical design of the building might not have been completed. But using historical data, we're able to estimate the designs and material consumptions, which allow us to forecast that material demand. And the reason why that's important is it enables us to buy more often from primary suppliers. For example, we buy from the lumber mill rather than a distributor or a local store. And it also allows us to negotiate better deals because we understand the volume in which we'll be purchasing over time, which, we found that typically results in a 5 to 10% material cost savings per category. So if you're able to do this for many categories, you can get significant savings in the overall material cost of the building. So, it's not one thing, I guess, that's trying to enable the Katerra vertical integration, but a lot of little challenges. And because there aren't many companies in the industry that are vertically integrated, we've taken the approach of developing some of our own software and systems to enable us to sort of benefit from that position in the market. I guess I know there wasn't much time. I'll stop there as an overview of some of the things that we're working on. Thank you very much.
Forrest, thank you very much. And thank you very much for the very clear presentation. And I saw that a lot of people were interested in your presentation because a lot of people came from all parallel sessions to this main session to hear your story. I'm just checking because I think I have two other people online. Aukje Kuipers, Director of Kuipers, and Lianda Scherps-Komen, Manager Business Development RC Panels. But for now, I also got a question via the chat. Forrest, one of the questions is, do you plan to extend your production to other types of buildings as well?
We do. For time reasons, I didn't speak to the CLT building type, which I think is quite an exciting material. I mean, it's actually more prevalent in Europe than it is in the US. But I think there are obvious extensions: student housing and hospitality, senior living. Those are areas that we're kind of actively looking to productize. And then the commercial office product, which is Class A office mid-rise building made out of CLT. I didn't have a chance to talk in detail about that today, but those are the next sort of building product types that Katerra will be exploring.
Okay, great. Thank you very much. Just checking if Aukje is already there and Lianda.
Yes, we're here.
Ah, wonderful, wonderful. Aukje Kuipers, may I ask you, you were listening also to the presentation of Forrest. Do you have any questions?
Well, it's very interesting to see how your production process is actually industrialized. I saw a presentation earlier today, and then in the sort of industrialization was a bit smaller. You took the big picture, as a real Americans do. Just go for the kill, I would say. What I'm interested in is how did you get so successful in such a short period of time? Because I have the opinion or the impression that you, in just a few years' time, you have been able as a company to integrate the whole chain. Is that correct?
Yeah, I will speak to that a little bit. So Katerra was received venture investment. I guess approximately 1.5 billion US dollars. So quite a substantial investment. So that enabled us to move pretty rapidly in terms of building out the factory capabilities. And then there were quite a few acquisitions, mostly on the general contractor side. So I guess that's part of the reason behind the growth. I mean, when I joined the business in early 2017, Katerra was, I think, 600 people, and now it's over 7,000. So quite a rapid growth, but I would say about 70% of that is by acquisition, which has been a challenge as well, right? Trying to bring different companies together to operate in a different way. So I wouldn't say, we're still trying to demonstrate profitability of the platforms, but there was quite a big bet placed by the investors to try to achieve this end of vertical integration.
Yeah, because Aukje, do you have the same ambition as well for
I'm
such
sorry?
a growth? Do you have the same ambition as well for such a growth?
Well, it's interesting. No, but I also look at Europe and especially the Netherlands, and we're not used to spending so much money for new ways of working. So that's a totally different approach.
Yeah, I mean, I think there's quite a challenge to that too, because it came, for example, initially Katerra was building a lot of projects to keep the factory busy. We're building a lot of projects from designed by others, which was quite challenging for the factory because there were no standards in terms. You're building quite a variety of different things, which is different for a new factory that is just starting to operate. So I think, at least from my perspective, learning the manufacturing business, I think there's quite a few lessons there, but it did force us to learn pretty quickly, right? As we took on quite a big backlog of work and tried to service that through the factory.
Yeah, and what I find very interesting is that you make it integrated to your building. So you say it's construction, but it's also the mechanical engineering and everything in the same product. So I think that's very smart to do it in that way, because everybody knows everything has to be in the building, but to squeeze it into one product, yeah, that's brilliant. Actually, you're legalization of the construction area. Yeah, that's exactly what you're doing. And that's quite interesting because you can also be very creative. Although you have standards, you can also make different buildings. So I think that's a mental step we still have to make in Holland, I would say.
Okay, great. Leonda,
Yeah.
may I ask you, do you have any questions for
Yes,
us?
for me also, it was a very nice presentation because there was a lot of similarity with what we are doing, but on another scale and with a slightly different product, but also industrialization in the building industry. And I think that, apart from scale, there is also a difference in that in the Netherlands we do all the things with all different smaller companies and have a chain of companies to achieve that integration and industrialization. And you have had a lot of money, as you said, to buy all the whole chain yourselves. Is that the only way to do in your perspective, or does it have some disadvantages as well? Because if you have a very large company that is consisting of all kind of acquisitions, how do you keep that innovative speed and the culture going forward?
I think that's a very that's a great question. I think because there's been models, right, where it really requires tight integration between the design and the fabricators. And I think that there's potential to have a technology solution there, right, where you basically allow different designers to communicate directly with, say, a network of fabricators to kind of unlock that connection. So I think that there is exciting potential in the future to have more of an open standard instead of having it completely vertically integrated within one company. But I think that it's perhaps easier as a starting point to have that within one, because I've been on, there's been a lot of discussion around that. I think a lot of interest on the technology side of how do you create a platform that connects fabricators with designers, and there's advantages to that by kind of servicing that capacity, right, that exists in the market today. But I think it is it's a harder problem because you're dealing with many different parties. So I think in the future that is where the industry will go. I don't know if you guys are thinking about that. I've seen a lot of interest on kind of that, what they call like industrialized construction 2.0, in which you have, the technology is enabling sort of the smaller players in the market to share information and to participate in that way. So it's, I think it will come. It just may take a while to arrive on that standard platform.
Yeah, thank you very much. It's also one of the discussions earlier this morning about this cooperation between all the different organizations and the necessity of standardized information, but also having a sort of openness towards each other, because you have such a lot of different small organizations, bigger organizations, private and public partners in this whole project. Jacqueline, may I ask you to ask the last question? Do you have any question for first, or maybe for one of the other people?
I found it a very interesting presentation, and I was really concerned about the Open Bim ID. How do you think, Forrest, that Bim and Open Bim will develop in the future?
I'm sorry, I'm having a little trouble with the audio.
Okay, so the question is, how do you see the future of the connection between Bim and Open Bim? I'm not sure if
to be honest, I'm not intimately familiar with Open Bim.
Okay.
And I think that's the essence of the difference, I think, because we're having a lot of discussion here about Open Bim, in which you have open standards in which people can really use each other's information.
That's correct.
Yeah, and that's maybe also the reason, also the answer on the question of Lianda, saying all those different organizations are able to work together because they share their information.
Is that the standard of like ISO type standard?
Yeah, that is one of the main topics also this morning. That's sort of standard now in the Netherlands, to make sure that we all work together instead of one organization having all the information, because there isn't one organization in the Netherlands. Yeah.
We think that it's important to have the data sustainable for the end user over the whole life cycle of the building. But maybe a last question. Is Katerra also planning to focus on the European market?
So I would say, no near-term plans to focus on the European market. I think we have, quite a lot of room to grow in the Saudi and U.S. market. So no near-term plans to go to Europe.
Okay. Okay, but that gives an opportunity maybe to the other people listening now, saying what Katerra is doing is wonderful, and maybe make a sort of European version of it, and we can learn from each other. It would be nice. First, may I thank you very much for your participation in this conference. And it's only early in the morning for you today, so I wish you a wonderful day today. And thank you very much for your contribution. And the same for Aukje and Lianda. Thank you very much.
Welcome.
Thank you.
Thanks for having us.
Thank you.